Now I'd like to introduce Kersey, who's here to help us from the EPA's WaterSense program. Kersey has worked in various sectors before joining WaterSense program. Recently, he was the program manager for EPA's Green Chill Partnership program. He also worked for 3.5 years at the California Air Resources Board implementing an incentive program for clearer agriculture equipment and ensuring that cap and trade incentive programs benefited disadvantaged communities. Prior to that, he worked with the state agencies to plan hydrogen fueling infrastructure for fuel cell electric vehicles. He holds a Bachelor of Science in Mechanical Engineering and a BS in Materials Science and Engineering, a Master's of Science, and a PhD in Environmental Engineering, all from the University of California, Irvine.
All right. Thank you for the warm introduction, Chris. I am grateful and privileged to introduce Holly Cannon, who will be joining me in presenting on this topic today. Holly is an environmental scientist with over 10 years of experience promoting water efficiency and sustainable facilities management. For WaterSense, she's helped develop technical materials to assist the commercial and institutional sector in implementing water-saving best management practices, assists with the product specification development process, and supports the WaterSense labeled homes program. She has also completed more than 30 water assessments of federal facilities and helped us, EPA, reduce our potable water use by over 40% from a 2007 baseline across our owned facilities. She is truly a key person in the program. Before we jump into the material, I just want to remind everyone that this webinar is part of a monthly series that Energy Star and WaterSense host for commercial and institutional facilities. Already this year, we've held 2 webinars about quick water wins. The first one being how small operations and maintenance changes can save you water, and the second one being water savings from capital improvement projects, which addressed how to go beyond that low-hanging fruit and take on retrofit or replacement projects. Recordings of these webinars are available on the Energy Star website if you're interested. And with perfect timing, coming up this summer, we'll have a webinar on how to save water outdoors with landscape and irrigation changes, and a webinar on how to save water in your restrooms. So please look out for those invitations to sign up for those webinars. And honestly, I'll also just note that if you've got a really great water saving story that you'd like to share with us and with a broader audience, please reach out. We'd love to hear it. Sincerely, we're always actively recruiting for our webinars and for more folks to be a part of the program. Okay. Oh, cool. Perfect. Of course, no slide deck is ever complete without an agenda. So first, for any new folks, I'll provide you with just a quick, brief background on the WaterSense program. Then I'll go ahead and shift things over to Holly, who will introduce you to water management planning, discuss water assessments, and will tell you how to conduct one such assessment to establish a water balance. Then we'll also go through some good resources to help you conduct a water assessment, create a water balance, and identify opportunities to improve water efficiency. Lastly, if time permits, Holly will present a brief case study highlighting the success of water assessments at EPA's own facilities. Again, WaterSense is a voluntary program that was launched by the US EPA in 2006. The program works to promote water efficiency so that we can help organizations and consumers save water for future generations. The WaterSense label, which you can see here, provides a simple way for consumers and businesses to identify water efficient products, programs, practices, and homes. Products that earn the WaterSense label have been independently certified for water efficiency and performance. The label is reserved for products that reduce water use by at least 20% and perform as well or better than standard models. There is a wide variety of residential and commercial products eligible for the WaterSense label that can be used in commercial and institutional facilities. I believe to date we have more than 45,000 product models that have earned the WaterSense label in 8 different categories, including indoor plumbing products like toilets, urinals, shower heads, and lavatory faucets. Again, all very important aspects of everyday modern life. and irrigation products like irrigation controllers and spray sprinkler bodies. More information on how each of these products can save a facility water is available on our website. In addition to these product categories, we also work closely with Energy Star to include water factors in their specifications, and as well, in kind, to consider energy savings in ours. For example, Energy Star certified clothes washers, dishwashers, and ice machines are all also water efficient compared to standard models. With that, now I'll hand over the virtual stage to Holly to tell you about conducting a water assessment at your facility and how you can then in turn use the information that you learn from your assessment to save water.
Thanks so much, Kersey, and a sincere welcome to everyone participating today. I am really excited to talk to you about this topic. I absolutely love getting out in the field and conducting these assessments. It's my favorite part of water management planning, so I'm happy to talk you through it all. Some of you may know that Energy Star and WaterSense have created guidelines to help facilities manage and reduce energy and water use. Listed here are the steps in that and a diagram to give you a visual representation of the process. This process is generally referred to as water management planning, and it starts with a facility making a commitment, and it ends or sometimes begins again, as we'll get into later, with a facility celebrating its successes after reducing its water use. The focus of today's webinar is really on step 2, which is to complete the facility water assessment and understand your current water use and opportunities for improvement. The outcome of that can help you with steps 2 and 3, setting your goals and then creating your action plan. Within commercial buildings, water use varies quite a bit depending on your sector of business and the water end uses you have at your facility. So WaterSense has pulled together the data available to create some basic water use profiles for some sectors. Those are illustrated here. But keep in mind that things like local climate, age of equipment, occupancy rates, whether you have irrigation for your specific facility can really change the water use pattern. So the only way for you to know how your building or campus uses water and where it consumes the most water is to conduct your own facility water assessment and develop a water balance. You can use graphs like these to give you an idea of where to look for water end uses in your facility, but you don't necessarily want to assume that your facility's profile is going to look exactly like this. One overarching recommendation for any facility before you get started is to call your water utility. It may sound counterintuitive, but many water utilities want to save water and they can offer a range of services that can be very helpful to you. They can help provide historical water use for your facility. They can offer expertise or assistance in conducting your water assessment. Some utilities will even conduct it for you. They have a program where staff can come out and collect all the information you need and really handhold you through the process. They may have rebates or incentives to replace equipment or implement other water efficiency upgrades. They may be able to sign you up for leak alerts where they will reach out if it looks like your facility may have a leak. And lastly, they may be able to help you benchmark your facility against similar facilities in your area to see how you compare. Assessing a facility's water use may seem like a very involved step in water management planning. And if you remember that first slide with those steps, it probably is the largest step, but it is absolutely critical. Before you can begin to make your facility more efficient, you need to understand where you're using water and how. The assessment's going to help you identify the sources of water that you have, associated water meters that should be monitored. It can help you start and maintain a comprehensive inventory of water using equipment and systems. And lastly, it can help you prepare a list of water savings projects to explore further. This slide illustrates the steps in conducting a water assessment. You'll need to first, there are a lot of desktop steps before you actually get on site and get your hands dirty. So you'll want to gather readily available information on the facility and sources of water, review recent water bills, and establish your water use baseline. From there, you can actually get out into the field, walk around your facility, inventory all your water using fixtures, equipment, systems, and processes, verify the performance of any existing equipment and fixtures, and then you can go back to your desk and calculate and create the water balance for your facility. The next several slides talk about the information to gather and the things that you'll do before going on site. Like I mentioned, this is really kind of a 3-step process. There's information gathering, at your desk at home, wherever you are. Then there's the facility tour where you're collecting data, verifying stuff, looking through the facility, walking around, and then you'll go back to your desk and do the last step, which is creating your water balance. So right now we'll talk about what you need to gather before you go on site. First, you want to collect some basic background, like the building type and function, including whether there are any potentially high water intensity operations. These are things like commercial kitchens, laundry services, laboratory equipment, a cooling tower, anything that may be a large water user, you'll want to note so you can make sure you look at it when you get there. You'll want to note the occupancy characteristics of the building, including the number of residents, number of full-time employees, visitors, and you also want to understand the male to female ratio. That is going to help you calculate how much water is used in the restrooms later on. You will want to understand the typical operating hours and any weekly or seasonal variations and take into account how that may impact the water use. So for example, schools may not be using a whole lot of water over the summer or over holiday breaks, whereas a hospital operating 24 hours a day, 365 days a year, probably has fairly consistent water use other than accounting for changes in climate, the need for more cooling and irrigation in the summer months. Lastly, you want to document the building's square footage, the number of floors, the year of construction or major renovation, the size of the landscape, any other characteristics that may be important. And then you want to look at the sources of water use. So you want to identify any sources, whether they're metered or not metered. The main source is usually municipally supplied potable water. Some facilities may also have access to reclaimed water that can be used for irrigation or cooling tower makeup or other functions. You may have an on-site source like surface or groundwater wells, or an alternative on-site source like rainwater you've collected, air handler condensate, recycled gray water. For each of those sources, you want to pinpoint and write down the basic meter and submeter information, including where that meter is, what end uses are being used by that particular source, and billing account numbers if you have access to them. And then for the not metered sources, you want to get a handle on what end uses are being supplied by those. You'll want to gather and review water bills from any metered source that you have, at least for the past couple of years, so you can understand the use patterns and the cost of water and wastewater. You'll at least want to collect 2 years worth of utility bills to establish your baseline. Ideally, you'd have 3 or more years so you can really see how your water use is changing from year to year. Some facilities handle and pay their utility bills in a central office, so you may need to contact them to get a handle on your bills, or you can call your water utility like we talked about earlier and they can help you. For unmetered sources, you want to gather anything that's going to help you estimate the water use from that. So pumping capacities, storage tank sizes, things like that. Once you collect all of your data, it's really helpful to create charts to visualize the facility's water use. This is a very simple chart showing annual water use for a facility over 11 years. That can help you establish your baseline. In this case, our baseline was 2007, and it was about 50 gallons per square foot. And it's helpful to see this graph so you can see their water use change over time. So within a 10-year period, this particular facility cut their water use by more than half. And it's really neat to see the visual of that. Here's another simple chart, in this case showing monthly water use for a facility over 2.5 years. It's not uncommon to see water use increases in the summer months for irrigation and cooling towers. Charting the water use can help you identify common usage trends. If you have multiple years of data, it's very helpful to include all of that data so you can see trends year over year. If you see outlier data like we're seeing right now in the summer of 2016, you want to try to interview facility staff or try to get to the bottom of what happened there. In this case, it could have been a leak that was resolved. It may have been that they implemented a water efficiency project in their cooling tower or outside that reduced their water use in 2017 and 2018. It may just be that the summer of 2016 was particularly hotter and drier and they had more cooling use. Another option that we strongly recommend is to visualize and track your water use in Energy Star's Portfolio Manager tool. This resource will allow building owners and managers the opportunity to track water, among other things you see here, energy, waste, and materials. And this can be, the water use portion can be tracked through the water tab. You can add all of the water meters you have and enter your water use data, paying special attention to the units that your meter uses, if it's gallons or cubic feet, and it can prepare these nice charts for you so you can really see your progress. Using your water bills, you're going to want to establish your baseline. So you'll want to choose a year or a set of concurrent years that are representative of your typical operation. So that year shouldn't contain any major projects, renovations, leaks, things like that. For example, you probably don't want to choose 2020 or 2021 during the COVID shutdowns as your baseline because that wouldn't be a great representation of business as usual. To establish your baseline, you are going to add together the annual water use from every metered and unmetered source that you have. It's helpful to create a baseline for all of your sources individually and then also for all of your water use together. So if something is going up, you can really pinpoint which water source that was from, what meter, and that can help you get to the bottom of what's going on. Your water baseline, your water use baseline is the bar for your facility. So you're going to compare future years and projects you implement back to that baseline. In addition to just having a total gallons baseline, you may also want another normalized benchmarking metric for your facility. You may want to look at the gallons used per square foot of your facility. That's known as water use intensity, and that can help you account for facility growth and help you compare to other similar facilities that may be a little larger or smaller than yours. If you have a specific type of facility like a hotel, you may want to be considering gallons per occupied room or per occupant. A restaurant may want to look at gallons per meal served. A manufacturing facility may want to look at gallons per unit of product so they can account for increasing and decreasing production over time. After collecting the general facility and water use data, you want to try to collect building plans or interview the facility management staff so you can start to understand the types of water using activities that you expect during the assessment. These categories can include domestic water use, primarily from bathroom fixtures and drinking, laundry from on-site clothes washers, food service in your commercial kitchen, ice machines, pre-rinse spray valves, dishwashing equipment, any heating and cooling equipment, particularly cooling towers, laboratory and medical equipment like steam sterilizers, vacuum pumps, equipment cooling. If you have an irrigation system, any pools, outdoor pools or fountains you have, and water treatment systems like water softeners or reverse osmosis systems. You also, if you are a specific type of facility, manufacturing or industrial, you may have specialized equipment that consumes water that's unique to you. So I did some facility water assessments at the US Mint, and they used a lot of water for coin production and coin rinsing. That's not on this list, obviously, because that doesn't apply to 99% of facilities, but you really want to think outside the box, think of anything unique to you, and make sure you write it down as something you want to look at when you're on site. So then you want to plan your visit. After you've reviewed your building plans, interviewed facility staff, you should have a list of water meters and sub-meters you want to put eyes on, a general list of fixtures, equipment, and systems you plan to verify. If you can pre-populate any information, you can model, make and models, flow rates, any other information that you have on the back end. This can help you just verify stuff on site instead of collecting information. It can be a little bit quicker. For larger buildings, you may want to establish a sampling plan. So you don't have to go into, you know, if you have a ton of restrooms, you don't need to go in every single one. For example, if you're a hotel, you might say, I'm going to go into 20% of the guest rooms and look at their toilet, faucet, shower head. And you know, if those are roughly similar, you can call your audit of those pretty good. If you're a hotel with 2 wings and one was renovated recently and another one's a little older, you'd probably want to go into 20% of each of those to make sure you have a sampling of what's going on in both vintages. Lastly, if you are not involved in the management of the facility that you're working with, you want to make sure to schedule a pre-site visit interview with any facility staff. That can help you understand their goals, their overarching priorities. It can help you confirm any facility details you've collected and get an idea of any pet projects that they may want to focus on in regards to water efficiency. That facility team can also coordinate meetings with third-party vendors or other specific staff. They may have an irrigation contractor, they may have a cooling tower water chemistry professional, and those are really great resources for understanding those systems and for getting an idea on recommended improvements or cost estimates for project ideas you may recommend. You don't need a whole lot of tools when you're going out, but here are a few items to have handy. You want a pen, a clipboard, and your auditing worksheets to keep track of your notes. A camera or a smartphone to take pictures of equipment, nameplates, leaks. You know, especially if you're going into a lot of facilities, it can really help jog your memory to have that photo. I have tons of photos of facility water use on my phone, so it's really good to have. A flow bag or a bucket and a graduated cylinder for measuring volume of any flowing water you find if you need to. A stopwatch or a watch with a second hand can help with that as well. A screwdriver or a pocket knife can help you open stuck meter covers so you can get those meter readings. And then a tape measure can be helpful for measuring various things. For example, you may want to recommend a project to capture air handler condensate and route it back to the cooling tower for makeup. You may need to know how long that pipeline may be to cost out the projects. An infrared temperature sensor or another thermometer can help you get a handle on water temperature. A towel is always helpful when you're working with water. And finally, if you have the means to get one, a temporary water or flow meter that clamps onto a full pipe can be very helpful in estimating water use from some end uses if there isn't a permanent meter installed. Okay, now we've gathered, that's all the background information you have to collect. Now you're ready for the facility tour part of the assessment, which to me is the most fun. This is getting your hands dirty and getting on site and looking at everything that you think that you should be seeing. There are a handful of things you want to do when you're on site. First, you want to take meter readings. You want to look at all those meters that you had associated with utility accounts, get the current meter reading, make sure that tracks with the water bill. I think I had maybe one case where I got on site and the meter reading, the units of the physical meter were different than what was on the bill. And you just want to check that everything is looking right, is consistent, makes sense. You'll want to talk to facility management staff and look for any logbooks or records of sub-meter readings. Oftentimes these are just on, handwritten on a notebook paper. You want to gather records of those because that can help you later figure out how much water is coming from that end use. Particularly look at any metered subsystems that may not have a utility bill. So if there's, cooling tower makeup water meter, you definitely want to take a look at that and read that. When you're looking at meters, you can check the leak indicator. It's usually a spinning black or red dial and or another indicator on electronic meters. And if you're not expecting water use to be going on at that time, that can give you something to look into and verify. You want to make note of any opportunities there may be for installing submeters on major subsystems. We usually recommend having a submeter on your cooling tower, your irrigation system, your steam boiler at a minimum. Oftentimes water treatment systems, it's helpful to have a meter. Really anything that's going to one end use that has a lot of water use, it'd be good to recommend a submeter there. You'll also want to identify the source of hot water. Hot water is used for a lot of end uses like commercial kitchen equipment, dishwashers, sinks, shower heads, clothes washers. If you are recommending a project that saves water, those projects are also going to save a lot of energy. You want to identify the fuel source of that hot water so you can calculate what that energy savings will be. This is typically natural gas or electricity, sometimes can be another type of fuel, oil or gas. You want to look at the nameplate, identify the make and model and the heating efficiency. If it's not easily identifiable, you can always Google it after the audit to try to get a handle on that. This is a great place to look for leaks. That is true throughout your audit. You always want to be looking out for leaks. And finally, you want to look at the temperature set point of the hot water heater so you can figure out how much, what temperature of hot water, how much energy they're using. You can confirm that with your infrared temperature sensor, and you can also measure the temperature of the water at various end use points. Then you'll really do your in-depth tour of the facility. You'll go through all their mechanical spaces, restrooms, outside, really anywhere that uses water, and you'll note any obvious areas for improvement, any leaks, any single pass cooling, any outdated equipment. Interview any personnel you come across to help understand the day-to-day operation and patterns. They also may have suggestions on things, water savings projects that they want to see done. You can capture detailed equipment and fixture information to help you estimate annual water use. So I guess I should have led with, you are going to want to estimate the annual water use of each end use eventually. So you have that baseline water use. We are now going to try to figure out how much water every end use uses and see how those compare. So you want to gather any information that you may need to make those calculations. Look for leaks. Plumbing fixtures can be notoriously leaky. You should look for dripping water or wet areas throughout the visit. If you can, use that bucket and stopwatch and manually collect water flow rate readings where needed, and use that clamp on flow meter if you have one. So now I'm going to talk about some particular end uses and the types of information that you want to gather from some of these so you can later calculate how much water they're going to use. Also, some of this information is important to capture because it may help you recommend a project and cost that project out. So for example, in restrooms, you want to note the number of fixtures in each restroom and what type they are. So are they flushometer valve toilets? Or are they tank type toilets? Are they single flush? Or are they dual flush? You want to note how the fixture is mounted. Is it on the floor or on the wall? This type of information is going to help you recommend a replacement if you want to do that. Excuse me, quick drink of water. You'll also want to figure out the fixture's flow rate or flush volume, which I'll go into in a second. And lastly, note any obvious issues that require immediate maintenance, like leaks or scale buildup. So when you're looking for those flow rates, you can oftentimes find it directly on the fixture. Faucets typically have their flow rate marked on either the aerator or the faucet body, such as the bottom of the faucet stem. Shower heads are often marked on a faceplate or around the outer edge near the thread that connects the shower head to the arm. And whenever possible, you can measure and confirm the flow rate of faucets or shower heads using a flow bag or bucket. Tank type toilets are usually marked inside the tank or on the back of the seat. Flushometer valve toilets and urinal fixtures are typically marked with their rated flush volume somewhere on the porcelain. As for the valve, newer models are required to be labeled with the flush volume, as you can see here in the bottom photo. However, older models don't have these markings. So if you have access to your facility's plumbing or stock room, you may be able to see the rating of the replacement valves that they have on hand. Even if there is a rating marked on the fixture, sometimes it's good to get into that stock room because they may actually be stocking replacement valves that have a different flush volume than they should be using, and it's good to make note of that. Alternatively, using the calculations here, you can always calculate what the gallons per flush could be from these fixtures. Not going to go into detail, but this table gives you just a rough idea of common flow rates and flush volumes you can expect to find based on the age of the facility or the age of the renovation, and that can help you determine likely flow rates and flush volumes if you're really in a pinch. Moving on to laundry equipment. First, you want to identify the equipment type. There's a lot of different types of equipment. There's residential and commercial style washers that may be in your facility, washer extractors and tunnel washers. Those tend to be installed in facilities with a more significant laundry load, like hotels, hospitals, things like that. You want to look at the nameplate, collect any make and model information you can. That will help you look up equipment specifications after the audit. You can try to determine the capacity, either in cubic feet, which is typical for residential or commercial washers, or pounds, which is more common for washer extractors or tunnel washers. And for residential and commercial washers, you want to identify the rated integrated water factor that represents the water use per cubic foot per load, and determine whether those washers are Energy Star certified. That's an indication that they're likely already water efficient. Energy Star products do also save water, so it's probably not a project you want to recommend if you do see that label. You want to talk to any laundry staff that you find, understand their operating conditions, how many loads or pounds of laundry are they running per day? Do they have any specialized equipment installed, like water recycling or ozone systems? Those are things they can really help you with if you can have a few minutes to chat with them. Moving on to commercial kitchen equipment, there are a few things you want to look for during the assessment. On the next couple slides, I'll get into specific products and information you want to collect. But first, let's talk about talking to the kitchen staff. You want to understand their typical operating patterns. So sometimes they're operating in waves, sometimes they're operating all day. Maybe they only serve breakfast and lunch like a school and not all meals. You want to get an idea of how often this equipment is running and also an idea of what their behavior is. So they may be leaving faucets running to make things easier for them. You want to look for any areas with continuous running water, like sinks being used to defrost meat, continuously flowing water-cooled equipment. These may present opportunities to recommend different behaviors or projects. With regard to the specific equipment, these are some things you want to look for. For pre-mint spray valves, like the one in the photo above, Those are used to pre-rinse dishes before they go in the dishwasher. You want to collect or measure the flow rate and get an idea of how often staff are using those, how long per day. EPA WaterSense did a big study on pre-rinse spray valves several years ago and found some different estimates on how long they may be used. So if you're not able to figure it out, you could search up their pre-rinse spray valve study for information on that. For dishwashers, you want to collect the make and model number, note whether it's batch, continuous, or flight type dishwasher, how many hours or loads per day, and the rated water use. The water use you can maybe look up later using that make and model number. For ice machines, the primary thing you're going to want to note is whether it's water-cooled or air-cooled. Water-cooled models often use single-pass cooling water, and air-cooled models are much more water efficient. You can easily identify air-cooled models by looking for louvers on the side of the ice machine, and if you're not sure, you can look up the model number. Oftentimes, the end of the model number has a W or an A at the end that can tell you water-cooled or air-cooled. You could also check the floor drain to see if cooling water is flowing. You'll also want to note if the dishwashers or ice machines are Energy Star certified. If you see that label, that's a good sign they're probably already pretty water efficient and you don't need to replace them. For food steamers and combi ovens, similarly, get that make and model number, determine how steam is delivered or generated for those, the number of operating hours. You can identify the estimated water use by looking up that make and model later. Those two products are also eligible for Energy Star certification. Dipper wells are found in really specific types of facilities, but you may find one. They're particularly in ice cream shops or coffee shops to rinse utensils that are in frequent use. They often can flow continuously throughout the day, so if you do come across one, take a flow rate measurement there. And then lastly, food disposals often require flowing water. You want to prevent the damage of those grinder blades, keep food out of the drain. They can be pretty water intensive. So if you can, take a flow rate measurement, otherwise collect the make and model number and the estimated hours of use. Note if they have maybe a load sensor or a foot pedal that's controlling that water use. You'll also want to look for equipment that uses single pass cooling water. We talked about ice makers. That's one common single pass cooling water use. It's a situation where city water is plumbed to a piece of equipment to remove heat, and it's typically from a motor or a compressor. And after the heat is removed, the water typically goes right down the drain. So if it's present and has the potential to be the single greatest water waster in your facility. It's commonly used for ice machines, medical and laboratory equipment, vacuum systems, air compressors, and often the flow of water could be controlled by a solenoid valve, so it's only flowing when that motor or compressor is running. But in older models or cases where that valve fails, which is very common, water could be flowing continuously. If you do see it, make sure you obtain the flow rate and the frequency. It's definitely best to recommend replacing single pass cooled equipment first and foremost with air cooled equipment, or also potentially recommending that they use an existing chilled water loop or their cooling tower for cooling. While not as inefficient as single pass cooling, cooling towers can consume a lot of water if you have them. Not all facilities have them, but larger facilities with high heat loads like hotels, hospitals, labs, larger office buildings typically do. How they work is beyond the scope of this webinar. This is another one of my favorite topics. So we have a separate webinar specifically dives into mechanical systems, some specifically on cooling towers only. If you're interested in learning a lot more, you want to go to one of those. The overarching goal of the cooling tower related to water efficiency is to maximize the number of cycles of concentration without putting the cooling tower at risk of scale, biofouling, corrosion, or other issues. And the cycles of concentration are a measure of how many times water is recycled in the tower before it's evaporated or blown down. So increasing the cycles is typically done by performing chemical or physical water treatment of the water that's recirculating. And we'll talk about what type of information to collect. And if you're interested in hearing more, again, attend one of those other webinars. So you'll want to talk with facility staff to get some information. What processes is that cooling tower feeding? What's the tonnage of the cooling tower? You may be able to estimate the tonnage from the chiller tonnage if you don't have it. You want to get an idea of the cooling season. What months is this tower typically operating? When are they operating each day? You also want to figure out the percent capacity the tower is typically running at. These systems are typically designed for peak load, but buildings are usually operating at less than peak. So you want to figure out where they're roughly operating. And lastly, you'll want to ask if what the current cycles of concentration goal is and try to confirm that with additional information we'll talk about on this slide. You want to look at any submeters that are installed and tracked. They can commonly have a meter on the makeup and blowdown line, so try to obtain records from both of those if those are there. You'll also want to check the conductivity controller to see what conductivity the tower is operating at and compare that to the set point. Comparing those or figuring those out does help you understand the cycles of concentration. So the values should be on the conductivity controller, and the controller should have a set point, and they should be trying to maintain the conductivity right below that set point. If they don't have one, it's a great project to recommend that they get a conductivity controller installed. You also want to look for scale, corrosion, biological growth, anything that may be indicating to you that the tower is not operating well. Look around the basin for any leaks or excessive drift. And lastly, you'll want to look and listen within the overflow drain to see if there's any water flowing. Towers have a blowdown line that water should be flowing to. They also have an overflow drain, and that one should not have water flowing to it ever. It's strictly there to prevent flooding in case of a malfunction. So if you do see water flowing to that overflow drain, like in this picture, there's a sign you got a stuck makeup valve or a float valve or something going wrong. So you definitely want to look into that. Conductivity, like we talked about, that's a measure of how efficient your cooling tower is operating. The higher number of cycles of concentration is the greater efficiency. So the cycles are largely dependent on the incoming water quality and the water treatment that you have available. You want to check that conductivity controller, like we talked about, check the set point and the current meter reading. If they're vastly different, there may be something going on. You want to try to collect any water treatment reports. Oftentimes there'll be a water treatment vendor. They leave a report behind monthly or quarterly that will have some information on it about the tower, type of maintenance they're doing, the water quality, and that can help you figure out the total water use of the tower. Moving on to landscape and other associated irrigation. This is another big water user and potentially complicated system. Depending on the facility's landscape size and climate, it can, like I said, be a very large water user. You may be in the Northeast and not have an irrigation system and it's not relevant to you, but in areas that have them, it's definitely something you want to look at. Talk to the facility staff, help you understand when in the year irrigation is occurring and how it is scheduled. Get the make and model number of any irrigation controller, determine whether it controls it based on a schedule, whether facility is adjusting the schedule. Is it a smart controller that responds to weather or soil moisture data? Also ask if they have a rain sensor or a freeze sensor, any type of sensor that can trip the irrigation system if those weather conditions are recognized. Determine if there's a dedicated meter and get those meter readings. If there isn't one, certainly recommend that one be installed on that system. And lastly, you want to determine the types of sprinklers and try to get a count across the landscape. So rotors use a rotating stream. They're typically used on large turf. Spray sprinklers have a fan shape and are used on smaller turf areas and landscape beds. And drip or micro irrigation emit a low flow of water directly on the root zone. Drip is usually on smaller landscape beds. You'll also want to note the total irrigation landscape area and each zone. If there are different plantings, say you have, an acre of turf and quarter of an acre of planted beds, you want to note that down. You want to check for any broken or leaking sprinkler heads and also look for sprinklers that are overspraying onto the building or pavement. Any runoff, pooling, puddling, that may be a sign of overwatering. And lastly, you want to keep your eye out for any landscape that could potentially be converted to a more drought tolerant plant or where irrigation may be able to be removed altogether. I will say that conducting a thorough audit of a landscape irrigation system can be very challenging without proper training. So it may be beneficial to recommend that the facility work with a certified irrigation auditor, like one certified through a WaterSense labeled program. Those certified irrigation auditors will collect all of the site data that you need, make recommendations on maintenance and repairs, determine the irrigation efficiency, recommend schedule adjustments, and overall make recommendations on how to manage water use. Depending on the amount of water that the facility uses on irrigation, these professionals may be able to substantially reduce water use. If I have time at the end, which I hope I do, I am going to talk about a case study where my firm worked with the EPA at all their own facilities, and we did actually contract out the irrigation audit portion of the work to certified irrigation professionals, and they came back with long reports with lots of recommendations, and it was really worth it. So for a complicated system like that, definitely go with a pro. It can really help you on that aspect. There are a few other end uses I didn't cover today, like laboratory and medical equipment, water treatment systems, and any of those specific uses that are for your facility, individually, like the US Mint one I described earlier. You want to make sure you don't miss anything that uses water, try to capture everything. Once you're able to conduct the on-site assessment and figure out where water is being used, you're now going to create your facility water balance to see if there are any unidentified sources or any water losses. So the goal is to account for all water use at the facility. This can be done using metered or sub-meter data, engineering estimates, or other calculations based on flow rates, flush volumes, and other equipment specs you collected on site. So for example, I may use irrigation sub-meter information to estimate how much water is used outdoors. And then I may do a calculation estimating how often staff flush the toilet, how long they shower, how much they use the faucet to try to calculate out their restroom water use. I'm going to add together all the measured and estimated water end uses from any individual end use. And that should equal fairly close to the facility water use baseline that we calculated at the beginning. So if the sum of those doesn't come within 10% of their total water use, you want to look for an unidentified source of water that you didn't see, a leak, or some other issue that may need investigation. So a water balance could look like this. As you can see, the water use is broken down by certain fixtures, equipment, or processes. For each end use, the water balance is telling you the annual water use in gallons, the percent of the total water use. That can also help you really hone in on where you want to save. Right here, you can see the cooling tower is using a majority of their water use. So if I were going to recommend a project, I'd probably hone in there. And you want to make sure you note down the basis of your estimate. So some engineering estimates here, some flow rate measurements on site, some meter data, all being combined to try to estimate where water is going at that facility. At this particular facility, there was only 6% of unaccounted for water use. So since that's not greater than 10%, I can assume, calculations aren't perfect, but I got pretty close and there's probably not a major leak or something I missed. WaterSense has a ton of resources that can help. We don't have time to go through the detailed equations for everything to create that water balance today, but I will say that, I'm talking about in a couple slides here, we have resources that can help you do all of those calculations. They're really detailed out. It's all on our commercial tools section of the WaterSense website. There are tools for conducting the assessment, including checklists. We have case studies. We have links to this webinar recording will be up there, upcoming live webinars, all of that stuff is on there. We have water assessment checklists. We have worksheets to help you with your building water survey, collecting your water meter data, your equipment and water use inventory. So please check out the links to those on this slide. And really the bulk of our resources and calculations come from this guide, which is called WaterSense at Work. It is a best management practices guide for commercial and institutional facilities. It was initially released in October of 2012 to help facilities understand, manage, and reduce their water use. And it includes best management practices on a host of water end uses. What's listed here are all of the section titles, but within each section, there is an individual document on every end use, most end uses you can think of. So the sanitary fixture section, we have a chapter on toilets, urinals, faucets, shower heads, laundry equipment, I believe, is in there. And within each of those chapters, we talk about a background about that specific type of equipment. We provide operation and maintenance recommendations. We provide a retrofit recommendation if there are any for that product, and a replacement recommendation. There's also the savings potential section, and that can help you calculate what you're currently using, how much water that is currently using for you, and how much water you could save. So really helpful resource. We are in the process of updating many sections of the guide. We've put out several revised chapters with more to come. So please look at those to stay up to date on where we are. We also have some facility-specific tools for guides and water assessment worksheets for specific property types, like multifamily properties and hotels. For hotels, the water use tool is an Excel-based tool that can help hotels estimate water use and calculate savings from potential projects. Links to both of those are on this slide. And aside from WaterSense, a bunch of other groups have very useful resources that can help you. FEMP has tools that are indicated to help federal agencies conduct a water assessment and establish a water balance, but honestly, they can be used really by anyone as a starting point. The City Energy Project's water audit guidance for commercial buildings helps walk through the steps of conducting a water assessment and includes other great information on water using systems, benchmarking, codes, and other projects. The South Florida Water Management District has a water assessment and self-guided water audit guide that can help provide information on how to perform both a basic and a more advanced water audit. Several of WaterSense's partners have developed tools and resources, including the City of Boulder's CII water assessment tool. That's for users without a technical background to help them conduct a basic water assessment and identify water conservation opportunities. And that was developed based on that WaterSense at Work Best Management Practices guide I talked about. Finally, to help you with calculate specific end uses, Energy Star has their commercial kitchen equipment calculator to help you calculate water use and potential savings from kitchen equipment. The Excel-based water map tool can help you estimate cycles of concentration for cooling towers and suggest some ways to optimize those. And FEMP has a guide for estimating unmetered landscape water use that can be very helpful. Okay, let's see. We do have some time, so that's good. So I will share a brief case study of EPA success. So EPA owns and operates offices and laboratories throughout the U.S. to support its mission. In response to some executive orders and other federal guidance, EPA contracted my firm, ERG, to conduct water assessments beginning in the early 2000s. And from about early 2000 through maybe 2019, 2020, probably right before COVID, we completed about 75 assessments of approximately 30 different facilities. So you'll notice that we went to many of those facilities more than once, which I think was a huge reason for their success. That can help you check up on previously recommended projects and just continue encouraging optimal performance. Sometimes when you go back a second time, you find something totally new that you missed the first time, or maybe a piece of equipment isn't operating as it was. It's always helpful to look at things again. These assessments helped guide EPA in implementing a bunch of projects to save water. The main ones that they implemented included adding submeters to those large end uses, cooling towers, irrigation systems, eliminating single pass cooling across the board, doing some plumbing fixture replacements of some of those older products. We helped them improve their cooling tower management. Many facilities implemented an air handler condensate collection project where they captured cool water from their air handler, the condensate collected, and they pumped it back to their cooling tower for makeup water. It's a really great matched end use. Air handler condensate is being generated in the warmest months. The cooling tower needs water in the warmest months. It's a no-brainer if you can make that happen at your facility. And we help them with a near elimination of irrigation water use. So as you can see, the efforts were incredibly successful. EPA's water use intensity, and that's gallons per square foot of building space, decreased by 40% since 2007. That's when we established our baseline. Even though we went to some facilities prior to that, that baseline was set at fiscal year 2007. Obviously, this didn't come without resource or capital investment, but you can see that water assessments are a critical tool in helping a facility or a portfolio save water. And I think EPA's commitment to assessing its facilities more than once really contributed to its overall success. If any facility was backsliding, using more water than they had been in the past, we always checked up on that. It was just a really aggressive and successful management of those facilities over that almost 20-year period. If you're interested in seeing some examples of water assessment reports or what we call water management plans, they do maintain them on the Greening EPA website. Each report has facility information, historical site use, a water balance, and our project recommendations from each facility. Okay, so as Kirsty mentioned at the start of the webinar, this is part of a monthly series that Energy Star and WaterSense hosts for the CNI space. There are more webinars coming up in the next few months that are going to go into detail about other aspects of water efficiency. So look out for registration links on Energy Star's page. And now, Chris, if you could pull up that poll, we have a poll coming up on your screen. And so speaking of all these upcoming webinars, we are wondering if anyone on the training has a case study to share on any topic. Take a moment to respond to that poll. We like to feature case study speakers on every webinar we can so folks can hear from real world examples. Those are usually a little more easy to digest than all the information I just threw at you. And usually the case study speaker has 10 to 15 minutes to cover their topic, much more than the 2 minutes I went through. And we asked them to talk about a baseline scenario or the condition, the project that they implemented, and then the results of that project. So what were the water and cost savings, how much did the project cost, and their lessons learned. So if you have a case study or you know of anyone that you could recommend, please say yes to this poll and we will reach out to you sometime after the webinar. And Chris, just let me know when to move on from that poll.
Looks like a majority of people have answered, so you're good to go.
Okay, thanks, Chris. Okay, and if you can't wait for our upcoming webinars and you really want to learn more now, there are recordings of last year's and this year's webinars on Energy Star's website. We have ones recently about cooling towers, sub-metering strategies. I do see some questions coming in the chat box about metering and sub-metering, so that could be a great one to watch, and anything else that may be helpful to you. So just some final thoughts to summarize. Contact your water utility. They can likely help you use Energy Star's Portfolio Manager to track your water use. It can make those fun little charts for you. Identify your meter locations and areas or systems for where you could sub-meter to get a better handle on that. Start your equipment and fixture inventory. And as you're doing that, look for leaks, malfunctions, or single pass cooling. That's that low-hanging fruit that you may be able to tackle right away. For more involved projects, create a list of those projects. You could try to cost them out, prioritize them, and figure out, which one you want to tackle when you get the right amount of money. And finally, I think repeating those assessments every 4 to 5 years can really help you with continual improvement. Here's the information to contact Energy Star or WaterSense. And with that, I will start answering questions